All right, so we have these quadratic equations and we want to do complete the perfect square using this rectangle method. So the problem is, get this color, this one, x squared minus, let me do this problem. So with the negative one, when there's negative, I'll tell you what to do. But right now, let's get the positive one. So p squared plus 2p plus 1 equal to 0, right? The one that ends up equal to 0. To do this, if you want to use rectangle method, this is what you need to have. You need to have here 2p, so divided by 1 is divided by 2 is going to be 1p, right? So you need to set this up so that you have here p plus 1 and p plus 1. And then because this is dividing p, 2p divided by 2 is just 1p, and this is where it comes from. Now this is a fast way of showing it, just doing it, fast way of doing it. It's going to be p plus 1 times p plus 1, but where it comes from, the idea is you have this p squared. P squared is just in square with the base of p, like p times p is going to be p squared, and then this 2p is just p plus p. And we want to convert this into perfect square method, means something to the second power. Perfect square method, like it's like 9, which is 3 squared. It's like 25, which is 5 squared. And it's like, for example, x plus 5 squared. Why? Because it's squared. So we want to have squared. So basically that means we want to have x plus 5 times x plus 5, right? So this is, now in your case, instead of x you have p. Is like, I can write this like, instead of x plus 5 I can say p plus 5 times p plus 5, right? This p is this p. What else I need to add here? In this case it's just 5, but in your case it's half of 2p, so it's going to be one of them a rectangle here and another rectangle here. When you're doing this kind of problems, you have three type of shapes that you're dealing. One of them is the big square, which is like, in this case you have p times p makes it p squared, and you have rectangles which they're like that, either they're like that. One of the, for rectangles, one of the dimension is always 1, and the other dimension is the one of the variables, whatever your variable you have. In this case p, it's just p. Or that rectangle could be like this, lined up here. Again, one of the dimensions should be 1, and the other dimension is the variable that you have. In this case, it's just p. So two shapes, one of them big square, the other one rectangles, and there's a very small one. It's a square like this, which has dimension of being having a unit 1, since it's square. So either one of those sides is 1. So these are three shapes that you're dealing with to set up, to play with those rectangles and create this perfect square method. This is 2p, basically is p times p plus p makes it 2p. So p plus p. What is area of this rectangle? It's always, in this case, is like, you see 1 times p is p. Here 1 times p is p. So we need to have a rectangle like that. That's why I drew these rectangles here. So area of this rectangle is p, and area of this rectangle is also p. So p plus p is going to be 2p. That's what we have. That's what we need to have. So see, this is just 1. This dimension is 1. This dimension is 1. So this plus this plus this is what? Just p plus 1. Again, this dimension plus this dimension here, basically height of this shape is just going to be what? P plus 1. That's why p plus 1 times p plus 1 is p plus 1 squared. And there is also another one, which is another number term here, which is this one. That's 1. That's a little squared. That's the one I was talking about. So that's going to fit here. So you see that we already have this perfect squared. And we don't need to add or subtract anything, because this quadratic by itself is a perfect square method. It's p plus 1 times p plus 1. See, this dimension plus this dimension. So that can be written to p plus 1 squared. And so if you FOIL this, you see that it's going to be p plus 1 times p plus 1. You can check your work. P times p is p squared. P times 1 is just p. 1 times p is just p. 1 times 1 is just 1. And p plus p is just 2p. So that's going to be p squared plus 2p plus 1. See, that's what we had here initially. Cool. So now let's do a little bit a problem which is a little bit harder than this one. Which one is that? This x squared. Is that which one? Plus 4x equal to negative 3. And then, so to do this, you have this x squared. So you know it is a square with a dimension of x and x. And you have this 4x. So you divide by 2, it's going to be 2 x's. X, basically 4 x's are there. So 2 of them here, that's 1. They're rectangles, as we just explained. This dimension is 1, that dimension is 1, and the height of it is just x, because right here it's x. And then same, so those are x plus x. This is area of this is what? Just x. Area of this is x, because 1 times x is x. This x times x is going to be x squared. Area of that one is x squared. Now, there's 2 more rectangles here. We have the height is 1, base of this is x, this is x. There's another one, because we need to have 2, because totally there are 4 of them. And area of this is 1 times x, that's x. This is 1, so 1 times x, x. This is x, that's 1 times x, x. So see here, so far what I've built is here x squared plus x plus x plus x plus x. That's just x squared plus 4x's. But I want to have perfect squared. So I need to have here, I'm just going to draw this right now, and then I need to have squares here. Not as big as that one, with the smaller dimensions. So what is that? So I need to have this, 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 this. If I have this, then I can say x squared plus 4x plus 4, because area of each one of these is just 1. Because 1 times 1, I just explained why. 1, 1, 1, 1. So it's just 4. And then you see it's a perfect square now. This looks like a square. And how can I write it to show by product of binomials? This is a binomial, which is x plus 2. Means 2 terms, has 2 terms. It's called binomial. And this one is also a binomial. It has 2 terms, x plus 2. See, x plus 2 times x plus 2 is going to basically, it's a rectangle. It's a square like this. This is x plus 2, and that's x plus 2. X plus 2 times x plus 2 is going to be x plus 2 squared, and is going to cover the total area, which is in this case all of these rectangles and squares. So we set it up, but I need to have these 4 squares which is missing, all these. Okay, to do that, I can add 4 here into this equation like that. I can add 4 there, but I need to add also that to the right side, because I just cannot add one thing on one side of the equation. When you have an equation, you have to add it to both sides. So what you're going to get, now if I add that, see, I created this. That's what I needed to have. Because of these 4 squares, I added this 4. But I need to add both sides, so I did. So this whole thing is going to become x squared plus 4x plus 4, which I needed. It's right here. And that's the area of the square, equal to negative 3 plus 4. But that's going to be simplified. So eventually, this is going to conclude that's x plus 2 squared. That's what it is. X plus 2 squared equal to negative 4. Negative 3 plus 4 is just 1. So we completed perfect square here. But if the question says, here, the problems that I'm doing is that it doesn't say solve the equation, or it does. Yeah, solve each equation, it asks. To solve this equation, let me rewrite the equation here. X plus 2 to the second power equal to 1. It's an equation. You want to solve and see what x is. You want to see what x is. To do that, we have to get rid of this 2, the square power. To get rid of the power, which is second power, you need to get the square root of both sides. And when you get even root, radical with even root, you're going to have 2 answers. Positive answers and negative answers. So you have to consider that. So you have to put the positive and negatives. This root, square root, causes this rad to cancel, and you end up having just x plus 2 equal to, here you have 2 answers. One of them is rad 1 with positive sign. Rad 1 is just 1. Positive sign is 1. The other one is x plus 2. I couldn't get rid of this rectangle. This pop-up keeps coming. I checked the setting. It's always there. X plus 2 equal to, the other one's going to be again rad 1, which is 1 with negative sign. Which is going to be x plus 2 equal to negative 1. And we're almost done. To solve for x, subtract 2 from both sides. For the first equation, x would be equal to negative 1. And then here's again, second one, subtract 2 from both sides. So this and this cancels. You get x equal to negative 3. So there are 2 answers. One of them x equal to negative 1, and one x equal to negative 3. So that's how you do these problems using this rectangles method.